Okay, so we're going to take a look at air mass notes. And at the very end of it, we're going to look at some lake effect snow that happened in the New York area a little over, well, quite a few years ago now in November in 2014. And this was the same storm system that I showed you with pressure and temperature grids that had happened. That snow had gone all the way down into basically almost every state in the US, but all the way down into Texas for sure. And so we'll take a look at that at the end. But this set of notes does have some questions embedded into it that you do need to go through because those questions will be on the test. So you want to make sure you do that. But we're going to talk and define daytime sea breeze and nighttime land breeze because we have, remember this, the land has uneven heating and cooling. The land heats up during the day when the sun hits it compared to the ocean, but it also cools down much faster at night compared to the ocean. Water is a good retainer of heat. It's a heat sink. It takes a lot to heat it up and slow it down. So during the day, we get the land heating up, creating low pressure because as the air heats up, touching the ground, it starts to rise, becoming less dense. And as it rises, you might get some flow going inland, but a lot of it goes back out to sea because this air is now more dense. It's higher pressure. It's compact together. It's cooler than the land, and it rushes in to fill that area vacated by the rising air, and you get these convection currents going of the heating, cooling, flowing in to replace, and you get, notice this, ocean breeze. You get a sea breeze during the day. And if we flip that at night, the land now cools down much faster than the water. So now the water is warmer. So at sunrise and sunset, you actually kind of get a little lull. And as the pressure, as the temperature kind of evens out and then starts to balance and shift, and as it changes its balance, the wind actually changes direction. So now it's warmer over the water. That becomes the low pressure and it starts to rise and it flows inward at the top and starts to sink down. And this land now cools it down much faster, creating higher pressure, which flows back out to sea to replace the warm air rising. And so now we call this a land breeze. So at night, the air goes from the land to the sea, hence land breeze. During the day, it comes from the sea to the land, hence sea breeze. And if you need to see it a little more in action, here is our warm air rising, flowing out, down. And obviously you're probably going to see diagrams like this on the test, so make sure you can differentiate. So this is our sea breeze because the arrow comes from the sea to the land. And remember, it's always named from the direction from which the wind comes. Where this one is a land breeze because this is where we get the higher pressure. It cools down faster and it's flowing out to sea, where the ocean water is now warmer than the land and it starts to rise, and we get that nice convection current going. In fact, this shows a 24-hour system where you've got the land heating up, sun goes down, breeze stops for a moment, starts to change direction because now the land cooled down faster, and we get our land breeze at night. And then as sun comes up, we get our sea breeze during the day, where it's coming in from the ocean and onto the land. And then again, sun will go down and it just goes back and forth. If you want to go and watch this, he is actually going to describe exactly the same thing I did. So if it helps you to watch another rendition of that, and he's actually by the sea, please go ahead and do that. But it's about 1 minute and 37 seconds. So go ahead and look at that if you wish. Now, interestingly enough, we've got our sea breeze, right? During the day, it comes in from the sea, and we have our land breeze at night, it goes out. The same thing actually happens in the mountains because during the day, the tips of the mountains actually heat up faster than the valley. And so this at the top of the mountain actually creates low pressure, hot air rises. And then you get actually something called a valley breeze because this is colder down here, more dense. But as this air vacates the area, this rushes up to fill it back up. It gets heated up and flows, and you get convection currents here too. So during the day, you actually get a valley breeze to try and cool you down. And at night, that cold air, because the tips cool down much more quickly now. So now the valley is actually the warmer air, and it rises, so the mountain actually sends air down the mountain to replace the stuff rising from the valley floor, and at night we get a mountain breeze. It's the same exact idea as our land breeze and sea breeze. It's about the heating and cooling, except this time in the mountains it's the tip of the mountain heating up and cooling down faster. So during the day, valley breeze, and at night, a mountain breeze. This is what we talked about a little bit in one of the videos that we did earlier on monsoons. So during the summer, when we have air rushing in from the water, from the ocean, to replace the hot rising air over India as its summer approaches, we get the monsoons. And monsoons are just this massive amount of rain, like amounts of rain that you would not even comprehend here. Let's take a quick look at that video.
The monsoon is a seasonal rain and wind pattern that was first described over South Asia. You see the cloud blossoming here during the summer part of the monsoon. For centuries, people had known about it, but only recently have we received enough data from satellites to really describe what's going on.
What you can see here is moist air that has evaporated from the ocean coming across India and providing rainfall, driving the monsoon season. The great thing about GPM is that it allows us to see precipitating systems as a whole, over land and oceans, and then as they transition from one boundary to the next.
All of this rainfall drives soil moisture over land. It's beneficial because it promotes the economic activity that people depend on. For example, agriculture. As well, it fills the rivers, which provides water for human activity and the natural environment, as well as transportation. If the rivers get too full, of course, it becomes flooding. At first, the floods you see here are fairly minor and broad scale, but then they concentrate in a few wiggly lines, which are the river basins, for example, in central eastern China.
In mountainous regions, when the ground becomes saturated due to heavy rains, it can lead to landslides. Landslides kill thousands of people every year and are primarily triggered by rainfall. They are especially common within the Himalayan region each monsoon season.
One really cool way to look at the monsoon is to do a split screen and look at the summer and the winter at the same time. In the summer, the wind is blowing onshore, bringing the moist, rain-laden air into the continent.
You can see the wind direction.
Off the continent.
Now those winds are basically driven by temperature differences between the ocean and the land. And where the land is nice and warm, the air expands and it draws in the moist precipitation from the ocean waters. But in the wintertime, it's very cold, and you can see that the moisture then goes from the continent back into the oceans. Over the past 50 years or so, satellites have been used to measure precipitation all around our Earth. With that data set, we're able to understand that monsoons occur not only in South Asia and India, but in other parts of the world as well.
For example, Africa, where the temperature gradient is between the Atlantic Ocean and the Sahara Desert. The wind blows from the moist Atlantic Ocean onto West Africa, providing the moisture for the precipitation. Some of these westward moving storms provoke hurricanes over the Atlantic that occasionally make it to the U.S. Southwestern North America also has a summertime monsoon. You see high soil moisture in regions where there's a lot of precipitation in western Mexico. Later in the season, this extends up into southwestern U.S. And the southern hemisphere has a monsoon as well. This occurs in the northern hemisphere winter, which is the southern hemisphere summer, when Australia is warmer than the ocean to the north.
Having a better understanding of the global water cycle and monitoring changes over time is important for society, for our everyday lives, and our long-term future.
Okay. So now we're going to take a look at our air masses, and they have specific names for where those air masses stay. So an air mass takes on the characteristic and the moisture and the temperature of where it originates. So let's say we're over Canada, way northern Canada in the middle of winter. If you're on the land, there's not a lot of moisture there, so it's going to be dry, and it's north of Minnesota, so it's going to be cold. So if it's a air mass that sits for a long period of time and takes on those characteristics, and it forms over land, it's going to be dry and it's going to be cold. Now, if you're over parts of Mexico and it sits there for a long period of time and maybe comes up north towards us, it again is going to be dry because it's over land, but it's going to be warm. Now, if I'm out here in the Pacific and I'm pretty far north, it's going to be cold, but it's going to be wet. Same thing if I'm over here. So basically, if it starts out over water, it's moist or wet. If it starts out over land, it's dry. If it starts to the north, it's cold. If it starts to the south, it's warm. So they have specific names. Polar means cold, continental means dry, maritime means wet, polar means cold. Down here, tropical, well, tropics, you think of warm, right? So now this is going to be maritime tropical if it starts over the water in the warmer area. So it's going to be maritime wet and tropical warm. Continental tropical is going to be dry and warm. Maritime tropical, now again, the land masses of the islands of the Caribbean are not enough to override the water surrounding them. So this would be maritime tropical, warm and wet. And that's really important. You're going to need to know those things. And here is the cheat sheet for it. So air masses have the properties from where they're formed. Continental air masses are formed over continents and are dry. Not a bad thing to add to your notes if you want to use them on the test. Maritime air masses are formed over oceans and are moist. Polar is cold. Tropical is warm. So here is the abbreviations. Continental or maritime always comes first. So dry or wet comes first, and then the temperature comes second. So continental polar would be dry and cold. Continental tropical would be dry and warm. Maritime polar would be wet and cold, and maritime tropical would be wet and warm. So if I go back up here, this would be abbreviated MT, CT, CP, MP. And there's going to be a question like this on the test where I'm going to literally have the United States along with Canada and Mexico, and we will have big circles drawn on there, and I'm going to say, okay, which one's maritime polar, which one is continental tropical, and so forth. So you're going to have to identify all four areas, just like you're going to come back and do here. So what will the weather be tomorrow? Is it going to rain on the way? Will sunny weather be moving in? Weather moves from place to place, but where does it come from? Where does weather start? Most weather comes from air masses. And an air mass is a huge body of air that covers a very large area. Places within this area have the same temperature and humidity or amount of moisture. An air mass that starts over the ocean or over a large body of land, that makes up an air mass that stalls over the water or land. So it stands still for several days or weeks. So during this time, the land or water gives the air its temperature and humidity, and air masses move on. Remember, humidity is the air mass depends on where it's formed. So air masses formed over the ocean are maritime and they're moist. Air masses formed over the continents are dry. Temperature then, polar is cold and tropical is warm. So we put the two together. The first part tells us either the maritime or continental, and the second part tells us whether it's either tropical or polar. For example, the name continental tropical tells us the air mass formed over tropical land, and it's dry and warm. And this is what you're going to see on the test. So looking at this would be continental because it's over, land. This would be continental, but this would be maritime. 4 would be maritime, 3 would be maritime, and 6 would be maritime. Anything in the north is going to be polar. Anything down by the equator is going to be tropical. And guess what you get to do when you come back to practice this? You need to fill in those names. Then you're going to answer a couple other questions from that reading that we just did. This is basically a section summary that I kind of put into the notes. So go back to the reading if you need. This is where you're going to get all the answers from. Go back and watch the video if you need. And now, when you're done with that, now we're going to look at some cool things that happens from these air masses. So this air mass started out over the Pacific. So it was maritime polar. It would have been cold. And we watched it literally come through Seattle, Oregon, that area, Northern California, all the way across the Rockies, all the way through the Great Plains, and then it went over the Great Lakes. And the Great Lakes are big enough to affect weather. There's enough time for that air mass as it goes over the Great Lakes, Lake Superior, and Lake Huron and Lake Erie and all of those, that it can actually gain moisture. And what you're seeing is kind of a combination of falling snow, but also moisture being pulled up at the same time, feeding these clouds. This is lake effect snow coming in from the lake. And it's just training. I mean, it's pulling moisture in. You can literally see the clouds are rising. You know there's snow falling too, but it is picking up moisture from that water second by second.
We're going to start with
Let's see if we can get this to play.
We're going to start with your hometown. There's a lot of snow there this morning. Yeah, people are getting pummeled because this relentless snowstorm is now blamed for 5 deaths around Buffalo, New York. This solid wall of clouds just south of Buffalo shows the power of that lake effect storm. Some areas could see up to 100 inches of snow by this weekend. I thought you were missing a lot of snow this morning. Hundreds of thousands of people are struggling to get out of their homes and clear the streets and sidewalks. Some of them spent 2 nights stuck in their cars. Jerika Duncan is in West Seneca, New York. That's just
You can see it
outside
was
of
snowing all the
Buffalo.
way from
Jerika,
Minnesota
good
all the way to
morning.
the East Coast.
Good morning. As you can tell by this snow, we are in one of the towns hit hardest by that lake effect snow. Now, on our way here, we passed several dozens, in fact, of abandoned vehicles, and Western New Yorkers are not out of the woods. This is just the beginning.
It was like a couple days of snow
Blinding
they
lake
had.
effect snow squalls and gusting winds pummeled parts of Buffalo, New York, and surrounding areas on Tuesday, dumping more than 5 feet of snow in some spots, falling at rates of up to 5 inches an hour. This time-lapse video shows a wall of heavy snow advancing toward the city. The snow began piling up early Tuesday, burying people in their homes and leaving drivers stranded along stretches of roadway. Close to 150 cars were stuck on a 4-mile stretch of the New York State Thruway, and 6 miles south of Buffalo, the Niagara women's basketball team was trapped on their bus for over 24 hours.
We're stressing to people, do not drive unless you absolutely have to. We've seen multiple people that had no reason to be out that are now either stranded in their car, injured.
New York Governor Andrew Cuomo issued a state of emergency in 10 counties. First responders scrambled to assist as many people as they could, but near whiteout conditions brought deadly consequences.
Sadly, we have to announce we found on individual today, 46-year-old male in the town of Alden. Car was buried under approximately 12 to 15 feet of snow, and he was found deceased.
Clearing a path under these conditions is even stopping snowplow drivers in their tracks.
Plows can no longer plow the snow. There's so much snow, it's basically like plowing a brick wall.
Now, early this morning, the snow was just coming down so fast and so heavy that you could not see in front of you. As you can see right now, though, the snow is starting to taper off, and this is expected to continue throughout today. But by late tonight, another round of lake effect snow will target those areas that have already been hit the hardest. Jeff?
All right.
So that was a newscast. You can watch more of these if you want. It kind of goes into the same thing. But to put this into perspective, this was a picture of that lake effect snow coming in from an airplane. They had down here just, a normal 2 to 4 inches. This would be a big snows here, 14 to 18 inches, 20 to 30 inches, 50 to 60 inches, over 70 inches of snow as it came right off the lake. And that's at East Seneca area. Here's Buffalo right there. This was a couple day snow event, so it wasn't just one 24-hour period. It was about 48 hours, 30 hours. But they had 70 plus inches of snow in one storm, and that is due to lake effect. And this was a person's picture, and they were marking the window with the time as the snow came in more and more, and now it's just, you can barely see out of the top. And when they open their garage door, can you imagine trying to tackle that? I mean, this is piled up this far. It's almost to most people. I mean, an average human is going to come about this tall. But look just beyond it, the drifts beyond it. you had to clear it. Where are you going to put it? I mean, how do you throw that up over your shoulder? You better hope you have a really powerful snow blower, because that's what it's going to take. In fact, the snow was so bad that some structures just couldn't handle it. The snow pressure was too great. And this may sound really weird. I mean, why would you snow blow and do extra work? But they were trying to get the snow away from the house so that as it melted, it wouldn't come directly in. Now, they had a lot of flooding that spring. This is a person that, you know, well, they started cleaning their car off, but where do you put it all? So they just left it on. I would not recommend driving that way. In fact, I think you're going to get some fines for that. And if it falls off, can you imagine how much is going to be left on the road? There is a hat of lake effect snow. And this was a pass underneath on a highway, where that is basically a bobcat with a huge snowblower in the front, and it's more than twice the depth. So that was some massive drifting that happened. They're just trying to clear it. So bad that if there was, that's an ambulance, this was a medical emergency. They were trying to get to the person, and the snowplow had to go ahead of the ambulances to get to the people who needed it. In fact, you can see people were blowing or walking, trying to get their cars out, just trying to get paths out. And got to find a place to put it all. Not to mention the fact that it's a lot of weight on your roof. You're going to find out that if you live in Minnesota, you have much different building codes than if you live in Florida. Florida, you have to have like hurricane clips to keep your roof attached to your house. In Minnesota and, you know, New York, where this was happening, you have to have codes for rafters that can really support the weight, because that is a lot of weight. And this is, I mean, you look at that, it's up to his hip, and they're trying to get it off the roof. This one was even crazier. I mean, look at that, it's over their heads. That's how much drifted on top of this roof. So just feel lucky when you just have to measure, you know, shovel maybe a couple inches or maybe a foot, because it's not like trying to deal with 5 or 6 feet. And again, here, look at the car. They started clearing out around it, but they're going to have to get rid of that at some point. And they have snow blowers and shovels. And they haven't even hit the road yet. The road hasn't been plowed. Can you imagine the plow spoil that's going to come in when they come with a plow? They had to, I'm sure, ship it out. And, you know, sometimes they'll dump this on lakes so that it melts into a water supply, or they'll find open fields to deposit some of this, but they would have had to literally take trucks and just start hauling snow out. There's no place to put it. And this gentleman had a picture taken because he was just trying to find his car. And here's just a little lone person trying to get their driveway cleared out to the road. So that's lake effect snow. Atmospheric circulations are what drive it. Remember, we live in the prevailing westerlies, and they went across the Great Lakes picking up more moisture, and boy did they get hammered. So atmospheric circulation really plays a big impact on our weather systems.
On a greater scale, we find regional winds affecting weather over larger areas. Generally, large land masses, or continents, heat more in the summer than large neighboring areas of water. And in the winter, this land cools more than the nearby water. These temperature shifts create wind patterns. For example, in Asia, we have monsoons, which are...
So this is just kind of recapping everything we've gone through. The fact that you have uneven heating of the land, creating sea breezes and land breezes. The same thing happens with mountains, valley breezes, and, you know, mountain breezes. But you need to understand that also drives monsoons. It also drives, you know, that those wind patterns, the global ones, make our prevailing westerlies determine which direction our weather comes from us where we are, and the bulk of the United States, it actually comes from the west. So this is a quick review, and the next thing we're going to start on is some weather forecasting. Just a quick review. Remember, Coriolis effect starts spinning, and I hope you have a great day. And if you need anything, as always, ask.